Greetings, math fans. All right, so this is Note Sheet 4, and this is again part of the probability chapter. So basically, today's topic is talking. Well, actually, there are two topics. So the first one is true, or we really refer to as false, positive, and negative. Okay, so let's just talk about what that means, because some of you have heard, like, if something is false positive or false negative, what does that mean? All right, so first of all, just kind of reading the second line here, it says true. If you're the best example is if you're sick and you go into the doctor and the doctor gives you a test. Okay, so if you actually have, let's say, pneumonia, or you don't have pneumonia, right? So it's one of the two. And the deal is, if you have pneumonia and the test tells you you have pneumonia, that's true. Okay, so if the test is true, that's what we call it. We have true, positive, negative. So true positive is the test is correct and it's saying you do have pneumonia. If you don't have pneumonia and the test says you don't have pneumonia, that's true negative, because the test is working, right? It's saying you don't have pneumonia and the test is saying you don't have pneumonia. Okay, that's cool. All right, so that's true. That occurs most often. All right, the false is when the test doesn't work. And again, that's kind of what I put at this very first thing here. All right, is I said true occurs most often because the test should give an accurate result. All right, if you're going to the doctor and the doctor is not really, the test is not working, and the doctor keeps making the wrong decision on what you have, okay, that would be bad, right? You wouldn't like that. You wouldn't go to that same doctor. So false doesn't happen very often. Okay, it's got to be somewhat true, because people want to have correct results. They don't want to have, you don't want to go to the doctor and the doctor say, oh, well, I think it's a 50-50 chance that you have pneumonia, so let me give you some medicine. You have no idea. So most of the time it's going to be true, whether it's true positive or true negative. All right, so the main thing that we're going to talk about really is false positive and false negative. So as I said down here, true, the test results are correct. Okay, and then you have false, which means the test result is not correct. Very, very important. Okay, and then positive means you actually do have the disease. Okay, so it's positive, that means you do have the disease or pregnant or whatever. And if it's negative, that means you don't have it, which makes sense. Positive is you do, negative is you don't. Okay, so let's just talk a little bit about what some of these mean here. I kind of try to put together a few little things I got off the web. Okay, so if we take a look at this chart, math fans, let's focus on a couple things here. First of all, let's focus on this guy right here. All right, so basically, if you have the disease, right, you go in there and you actually have the disease and you're tested positive, that's what it's meant to do, right? That's called true. Okay, that's why we say this is true positive. I'm not really going to worry about the true so much. But let's say you go in there and the doctor, and you actually have the disease, but the doctor says, no, you don't have it. I just tested you don't have it, but you really actually do. So that's actually a false negative, because they're saying, the test is saying you don't have it, but you do. All right, you actually do. The test is wrong. So it's saying you don't have it. That's why it's negative. All right, so let's do the other column now. And let's look at this one first. Okay, so you don't have the disease. You go in there, you don't have the disease, and they do a test on you and they say, nope, you don't have it. And you're like, oh, okay, cool. So that's why they call that true negative, because the test is correct and it came back negative because you don't have the disease. But if you go in there, so now let's look at this guy right here. All right. Again, you don't have the disease, but you go in there and they say, oh, no, you got a disease. You're sick. All right. That's false positive, because they're telling you, yes, you do have the disease. It's positive. The test came back positively. You do have the disease. All right. So that would be false because it's wrong, and positive because it's telling you you have the disease when you actually don't. Okay. So that's the difference between false positive and false negative. False means the test was wrong. False positive means it's saying that you got it, it came back positive, you have it, but you don't have it. And false negative means again, the test is wrong and you really have the disease, but they're saying you don't. Okay, and if you don't have it, that means that's false negative. It's saying you don't have it. Okay, so that's the difference between the two. And I did this little chart over here, math fans, just to kind of show you that true occurs so much more often than false, because here's true and here's true. It occurs more often because the test should be right. All right, and just a little bit of false right here, because most of the time the test is not wrong. And this even shows you another little graph here showing true negative and true positive. Right? If you have the disease, you got a true positive. If you don't have the disease, you got a true negative. Okay. Actually, if you have the disease, it's true positive, because it means it's positive that you have the disease, and true negative means you're healthy. All right. But then you got this. This is the false positive, false negative right here. Small part of it, which is again not very significant, because the test is usually correct. Okay. So let's try a problem here. Professional bodybuilders are tested for steroids every year. They are given a test in which 10% false positive result and a 15% false negative result. It is commonly known that 20% of all bodybuilders use steroids. All right, so this is what I suggest you guys do. I left a nice big space here. First of all, I know that 20% of bodybuilders use steroids. Okay, so I'm going to make a nice tree here. And basically, I'm going to say this one's use steroids, so I'm going to call it roids, just to shorten it. This one uses roids, and this one doesn't, so don't use roids. And 20% use steroids, and 80% don't. Okay, and then you can either be tested positive, or you can be tested negative. Same thing with this one, tested. We'll put it on top here, keep it consistent. Tested positive or tested negative. So let's talk about what each of these means. If you use steroids and you're tested positive, that means the test was correct. Okay. If you use steroids and the test comes back says no, you don't use steroids, that's false. All right. So this right here, I'm going to put this in a different color. This is actually a false negative here, because it's saying, or you use steroids and the test comes back false, that you don't. So it's negative. It's a negative. It comes back negative, which means you don't use it. That's why they call it a false negative. So this gets 0.15 because it says a 15% false negative. Okay, and then this one gets, it's basically 0.15 and then 1 minus 0.15, which is 0.85 test positive, which makes sense. If you use steroids, the test is usually going to come back as positive. That's why it's 85% sure that it's going to come back correct, positive. Okay, so now let's go to the next one. Don't use steroids. All right, so the next thing I'm going to use is it says 10% false positive. All right, so if you don't use steroids and the test comes back as saying, hey, you do use steroids, that's false, and it's coming back saying you use them, so it's coming back as a false positive, because it's coming back that you use the steroids and the test came back positive. That's why they call this false positive. So this is false positive, and that is the 15% or the 10%. So this is 0.10, and then of course this is going to be 0.90, and which it should be higher, right? Because if you don't use steroids, it should come back as you don't use steroids in the test. That's why it's 0.90. Okay? So notice, math fans, these add up. Like this guy right here, that adds up to 1.0 because you either use steroids or you don't use steroids. Same thing with this one. Okay? You're either tested positive or negative if you use steroids, and same thing with this one. You're either tested positive or negative if you don't use steroids. Okay? So those are the, let me take these circles away here. But those are the probabilities we're going to be using now for these next couple problems. All right, so if a bodybuilder is chosen at random, what is the probability that he uses steroids and tests positive? So the probability, so you just have to follow the chart. So bodybuilder is chosen at random, probability that he uses steroids. So if I follow this, he uses steroids, so he uses steroids and he tests positive. So let me move this down just a little bit. So he uses steroids and tests positive. So we're following that line right there. Okay, so it's basically 0.2 times 0.85. So I can write this out here. Probability of use roids and test positive. That's why it's multiplication. Okay, and is multiplication. So it's basically 0.20 times 0.85, which gives me 0.17. So think about that probability. It's actually pretty low, isn't it? So first of all, why is this number low? Because is the test correct? It says he uses steroids and he tests positive. So yeah, okay, the test is correct because if he's using steroids, he's testing positive. Well, why is this number so low? Well, part of the reason is because only 20% of the bodybuilders actually use steroids. So of course, I'm picking a random bodybuilder. Okay, not somebody who uses steroids, just a random bodybuilder. So only 20% use steroids. So of course, picking a random bodybuilder, only 17% are actually going to be using steroids and then also test positive. Okay? B, if a bodybuilder is chosen at random, what is the probability that he uses steroids and tests negative? Okay, so he uses steroids. So let me erase this yellow guy right here. Okay, so he uses steroids and tests negative. So it's kind of the same thing. Uses steroids and tests negative. So it's just you changing the probability. In fact, the next two of them after that, if you look at it, let's just kind of go through this. The next is C. What is the probability that he doesn't use steroids and test positive? So doesn't use steroids and test positive. Okay, and then D is if probability he doesn't use steroids and test negative. So doesn't use steroids and test negative. Okay, so you just multiply those out. So let's actually fill this in here. All right, so this is going to be probability of using roids times probability of testing negative, and that's basically 0.20 times 0.15, which is 0.03. Okay? Because again, that's pretty low, right? So first of all, the probability that you're using steroids in the first place is 20%, and then for the test to be wrong, even is lower probability. That's why it's just 0.03, 3% chance that person you'll pick is a person who actually uses steroids, but then when they got tested, they tested negative. Doesn't happen very often. Okay, this one bodybuilder is chosen, probably doesn't use steroids. So again, this is going to be probability of no roids times the probability of test positive. Okay, so we go back up here. Probability of not using steroids is 0.8, and then test positive is 0.10. So 0.80 times 0.10. So that gives us 0.08. So we'll talk about that probability. So first of all, it's a higher probability that he doesn't use steroids, right? So that's what the 0.8 comes from. But if he doesn't use steroids, but he's tested positive, that means the test is wrong and he's saying, hey, yeah, use steroids. That's, again, pretty low probability that's going to happen. Okay, that he's going to actually, that he's not going to use steroids, but yet he's going to be tested positive. So what do you think about D? D is actually, what is the probability that he doesn't use steroids and he also is tested negative? So the test says, hey, you don't use steroids. That should be the highest. All right? Because most of the people are not going to use steroids, and if you get tested by chance, you're going to get tested negative because it's going to say, yeah, you're right, you don't use steroids. So this one is probability of no roids times probability of test negative, and that's going to give us 0.80 plus probability of not using steroids, and probability of getting test negative is 0.90. So the answer comes out to be 0.72. Okay, so I want you to understand that we've covered all cases, right? If you have steroids, you're tested positive. If you have steroids, you're tested negative. If you don't have steroids, don't use roids, you're tested positive, you're tested negative. So if you look at it, math fans, if I add up all these numbers, what are they going to equal? Okay, it actually equals 1.0, which makes sense. All right, because 1.0 means it's going to happen. So if I add up all the probabilities, one of those four cases have to happen. If I add them all up, it comes up to 1.0. Okay? All right. So let's keep going here. If a bodybuilder is chosen, what is the probability he tests positive? So I'm just telling you now he's testing positive. So what you need to do is go back to our chart up here. All right, I'm going to get rid of these yellow lines here. Okay, so again, if the bodybuilder is chosen, what is the probability he tests positive? Do you guys agree testing positive is, it could either be using steroids test positive or not using steroids and testing positive? It's one of those two. So it's using roids test positive, or ding ding ding, what does the word or mean? It means add. So I'm going to do multiplication for using steroids and testing positive, or you don't use steroids and test positive. So you can see there's multiplication, there's addition there. So let me write this out here. Okay, it's going to be probability of use roids and test, probability of test positive, or, so it's plus probability of no roids times probability of test positive. Okay, just pull that off the chart. So it's going to be 0.2 times 0.85 plus 0.80 times 0.10. And you put it all together and you get 0.25. So basically what I did here, math fans, is this is A plus C from this couple examples ago. Okay, that's all it is. Because A and C, if I go back here, A is probability of using steroids and test positive right here, test positive, and C is it doesn't use steroids and test positive. Okay. All right. So this one is that he tests negative. So really, when you test negative, that's just going to be if you look at it, that's B. Okay, so it's going to be B and D. So it's going to be test negative and test negative. So it's just going to be adding those two together. Okay, so that's basically the probability of no roids, probability of roids times the probability of test negative plus the probability of no roids times the probability of test negative. Okay, so that's 0.20 times 0.15 plus 0.80, because again it's or, times 0.90. And that gives us 0.75. So once again, math fans, these two probabilities add up to 1.0 because you either tested positive or you tested negative. Okay? All right. So last one here. If a bodybuilder already took the test and it showed that she did take steroids, got to take she in there too because women take steroids too, which is bad. Okay? So a bodybuilder already took the test and it shows that she did take steroids, then what is the probability that she actually took the steroids? So here's the deal. The test says she took it. So we're going to use a conditional probability. Okay, we're going to do probability given that the test showed that she did take steroids. Okay, so basically it's you're tested positive, that's your given, and I'm asking what is the probability that she actually took the steroids. So this is the deal. This is the probability. What's the probability that she actually used steroids given that the test showed positive? Because it says the test showed that she did take steroids. Okay? And you guys should know by conditional probability that we learned already, that's equal to the probability of use roids and test positive divided by, remember, this goes underneath here, so it's probability of tested positive. Okay? So, probability of using steroids and tested positive, we did that, that was A. So if I cursor back up to A, right? A says use steroids and test positive. So I'm just going to use that here. It's it's point, I can show my work here real quickly. 0.20 times 0.85. And on the bottom, it's probably tested positive, and we did that already too. That's 0.25. That's letter E, but that's basically 0.20 times 0.85 plus 0.80 times 0.10. Okay, that's the probability of actually testing positively, which again, if you look, that's what we did in E, right? Tested positive. Okay, and just be careful. Make sure you use like lots of parentheses for that bottom guy right there. Right, and your answer comes out to be 0.68. Okay, so thinking of this probability here, or just the answer, if the bodybuilder already took steroid or already took the test, so the test showed that they took steroids. What's the probability that they actually took it? Well, if the test shows it, then the probability is kind of high, right? So that's what the deal is. So the probability is relatively high because the test is showing, yeah, you know what, you took steroids. Well, I hope it's probably pretty high that they actually took steroids. Hopefully the test is doing a good job. Okay? All right, cool. So let's move on to our last problem here. It's a little bit different than false positive and negative. It's just another type of probability which we need to go over here, okay? So let's talk about that. Okay, so the probability that you'll get an A++ of this test is 0.23. Okay? The probability, and we'll talk a little bit more what that means because it's a little bit more in depth here, okay? Anyway, the probability that you'll get an A++ on this test and the final is 0.12. And then the last one is the probability that you will get an A++ on at least one of these tests. So it could be the test, the final, or both is 0.41. So those are the three different probabilities you're given. All right. So let's look and see what they're asking for. It says find the probability of not getting an A++ on either this test or the final. So the deal is, you're saying you don't want an A++ on anything. You want an A++ on nothing. So let me draw out the scenarios here. I think this is just kind of good to draw this out. You're either going to have no A++s at all. You're going to have an A++ on the test. You're going to have an A++ on the final. And you're going to have an A++ on both. So I'll put both T and F, test and final. Okay? So if I ask you, find the probability of not getting an A++, I'm looking for this, right? Well, look at this guy right here. This is the probability that you get an A++ on at least one of them. Well, at least one of them, do you guys agree? That's this. at least one of them is the test, final, or both. So the way I figure out the probability is basically if I can just do 1 minus that rectangle. 1 minus the rectangle. That gives me the no A++ at all, right? Because one of those 4 cases has to happen. So if you know the one with a rectangle and you subtract that, you get the no A++. So it's basically 1 minus 0.41, which is 0.59. That's the answer. Okay? All right, B, find the probability of getting an A++ in the final, but not in this test. So let me write this out again here. No A++. And I'm just going to write, well, here, I'll write A++ in the test, A++ in the final, and A++ in both the test and the final. All right, so I am looking for the probability of getting an A++ on the final, but not on the test. So I'm looking for this right here, A++ on the final, but not on the test. Okay? So here's the deal. Again, we know this. Right? We know that. Everybody okay with that? And not that I can hear you, but that's okay. So you're looking, you're given this. That's your at least one of the tests. Now, this is actually really important, and I stressed this the first time I taught this, and the kids finally got that. So here's the deal. If I told you you will get an A++ on this test, and that's 0.23, what I'm referring to is this, an A++ on the test, but I'm also referring to this test as well. And you're like, well, Mr. Kerfus, this one says both. But I want you to understand that the statement above here, that I'm reading, this guy right here, it says the probability that you will get an A++ on this test. It doesn't specifically say just on the test. If I use the word just, I would be referring to just the test. Okay? But because I'm saying, hey, what's the probability to get an A++ on this test is 0.23, not just this test, I'm referring to this one and this one. I'm referring to both of them. Okay? So it just happens to be both. It's included with the final exam, and it's also the one individually for the test. So here's the deal. If I take my rectangle again, all right, so let me draw this out here. If I take the rectangle and I subtract the probability of getting a test, all right, so it's going to be basically the rectangle minus the 0.23, minus what I have in red, so minus this. That gives me just this, A++ in just the final. Does that make sense? So that's important that you understand that. Obviously, this I'm going to cross this off because it doesn't say just. If it was just, it would make a difference because we would just be referring to this guy right here. But it's saying the probability you get an A++ on this test is 0.23. So it's both of these, both this guy and this guy. That's the 0.23. So if I take the rectangle and I subtract those two, I get an A++ in the final. All right. So basically, that's a lot to explain. But basically, the probability is, also right here, probability of at least one, right? One of these tests minus the probability of the test, which is 0.41 minus 0.23. Which comes out to be 0.18. Okay? All right. And then the last one here says find the probability of getting an A++ in only one of the two tests. So let me write out the scenarios again. No A++, A++ on the test, A++ on the final, and A++ in both the test and the final. So So it says find the probability of getting A++ in only one of the two tests. Well, do you guys agree? We're kind of using this again, guys. Right? That's the this guy right here. Right? The 0.41. So let me just write that out. That's 0.41. And I want to know the probability of getting an A++ in only one of the two tests. Only one. Which means I don't want this one. This one's got to be eliminated. So we're going to subtract that one and we'll look at the probabilities, what we're given. Here it is, man. Right there, that middle one. The probability you get an A++ on this test and the final. That's both. And that's what this is. That's both. So that's 0.41 minus 0.12. And that gives us 0.29 as an answer. Okay? All right, so that was a little lengthy as far as, but I tried to explain everything, try to diagram it all. Obviously, once you get used to it, you can kind of just figure out the probabilities, and that's what the homework is, and you guys have a review sheet. Of course, this is going to be on the quiz. I can guarantee you it's on the quiz. It's on the test. And you need to know this stuff on the final exam as well. All right? So that is it with true and false positive negatives and also some additional probability. And hopefully you guys are good to go. All right? That's it, man fans. Adios. Goodbye.